The content shared on this channel is for informational and entertainment purposes only. Always consult and follow the official and approved aircraft maintenance manuals and procedures provided by the manufacturer or relevant aviation authority before performing any tasks on an aircraft. The information presented here does not replace certified training or authorized technical documentation. Safety and compliance come first. Closing MEL items, why sooner is better. But before that, let's see what is an MEL. A Minimum Equipment List, MEL, is a list which provides for the operation of aircraft subject to specified conditions with particular equipment inoperative, which is prepared by an operator in conformity with or more restrictive than the MEL established for the aircraft type. It is not always possible to repair a system failure before the next flight. The MEL permits the dispatch of an aircraft with inoperative equipment or functions for a limited period of time and under specific conditions while maintaining an acceptable level of safety. Current in-service data shows an increase in the number of requests for MEL extension, indicating an increase of departures with multiple open MEL items. Even if dispatch under MEL always guarantees an acceptable level of safety, it increases the risk of exposure to multiple failures with their inherent operational consequences. This article recalls the importance of fixing MEL items at the earliest opportunity to reduce this risk of exposure to multiple failures and provides best practices where MEL extensions are necessary to maintain the highest possible margin of safety. There was an incident on an Airbus 330 aircraft that was dispatched on a non-ETOPS flight under MEL item 361101A engine bleed air supply system on engine 1. Before departure, engine 1 bleed push button switch was set to off, the cross bleed selector set to open, and APU bleed were confirmed as operative, as per the dispatch condition of the MEL. During the cruise phase at 39,000 feet, the air engine 1 and 2 bleed fault ECAM alert triggered. The flight crew followed the ECAM instructions and managed to reset the engine 2 bleed system. 20 seconds later, the air engine 1 and 2 bleed fault ECAM alert triggered again. The flight crew attempted to reset the engine 2 bleed system, but the reset was unsuccessful. The flight crew then declared a pan-pan situation to ATC and requested to descend to 10,000 feet. The cabin pressure excess cabin. Altitude ECAM alert triggered. The flight crew put on their oxygen masks and performed an emergency descent. Passenger oxygen masks automatically deployed during the descent. At flight level 19,000 feet, the flight crew started the APU and set APU bleed to on. The APU bleed remained on until the end of the flight. At 10,000 feet, the flight crew again attempted a reset of the engine 2 bleed system, which was successful. A decision to divert was taken, and the aircraft climbed to 17,000 feet, then performed an approach and landed without further events. With the MEL applied for the inoperative engine 1 bleed air supply system, the failure of the engine 2 bleed air supply system during the flight led to the loss of cabin pressure at cruise altitude, requiring an emergency descent and diversion. This had a notable operational impact, including the impression on the passengers who were aware of the sudden descent and observed the deployment of the oxygen masks in the cabin. Despite the significant operational impact, an acceptable margin of safety was maintained throughout this event thanks to the correct application of the MEL item dispatch conditions and operational procedures by the flight crew. The impacts of one inoperative engine bleed system, combined with a subsequent failure of the other engine bleed system, are described and addressed in the dispatch conditions and operational procedures of the MEL item. The condition of an operative APU bleed and the likelihood of passenger oxygen masks deploying when at cruise altitude above 37,400 feet are also described. An increase of the operational pressure to fly is observed. In addition, various operational constraints such as supply chain disruption affecting parts availability or the lack of qualified maintenance personnel may make it difficult to repair or replace the equipment within the time frame allowed by the MEL. This leads to an increase of the number of aircraft dispatched with open MEL items and therefore an increased exposure to multiple failure situations. In-service reports also show that the number of incorrectly applied MEL items is increasing. In limited cases, the initial MEL repair interval time can be extended to face the dispatch challenges. A one-time extension of standard repair intervals category, BCD, is possible, as defined by regulations. Where applicable, this one-time extension is taken into account in the safety analysis of each MEL item. An acceptable level of safety is therefore maintained for such cases. A dedicated process for the application of one-time extensions must be defined with the operator's National Airworthiness Authority. The MEL defined by the operator for their aircraft is either as restrictive or more restrictive than the MEL provided by the OEM for the aircraft type. An operator has the option to operate the aircraft outside the conditions of their MEL provided it complies with the equivalent conditions of the MEL. An acceptable level of safety is maintained as the dispatch remains within the certified MEL scope. It is, however, considered as a deviation from the operator's MEL, and formal approval must be given by their relevant National Aviation Authority each time this option is required. To avoid AOG situations, under exceptional circumstances, Airbus has developed a process called Approved Deviation to OSDM-MEL ADOM. It is a document issued by Airbus to support operators if they need to urgently dispatch an aircraft outside of the scope of the MEL. For each ADOM, a safety analysis is performed following the same safety methodology as for the development of the MEL items, refined to the actual aircraft status, and the planned mission to ensure that sufficient safety margins are maintained. Additional limitations can be required. An ADOM is an EASA-approved document and can be used only for deviation from the EASA MEL. It cannot be applied for the FAA MEL or the TCCA MEL. For the FAA MEL, extensions for intervals A and D and additional extensions can be granted on a case-by-case basis by the FAA, according to FAA Advisory Circular 120-125 and FAA Order 8900-1. ADOM can be used to further extend the repair interval A or the other intervals B, C, and D following the first extension, or to dispatch the aircraft with a combination of open MEL items not permitted by MEL or when the operational or maintenance procedure cannot be applied. It is a document issued by Airbus on a case-by-case basis, following analysis of the specific aircraft configuration and conditions. It is valid for a limited period of time, and operators have to obtain authorization from their relevant National Aviation Authority to apply the MEL deviation in accordance with the ADOM. The ADOM is only issued if the safety analysis demonstrates that an acceptable level of safety margin can still be maintained. The number of ADOM requests has increased significantly each year since 2021. One reason is the difficulty to obtain parts due to the post-pandemic supply chain challenges. This can further delay the repair or replacement of the affected equipment, increasing the exposure to multiple failure situations. The ADOM has to be used on an exceptional basis. Dispatch with open MEL items requires specific attention from both flight crews and maintenance crews with dedicated tasks. In case of extended MEL items and multiple MEL items, those tasks can take more time, be more complex, and have a significant impact on the crew's workloads. It is the responsibility of the flight crew to review all open MEL items, confirm that the associated dispatch conditions and limitations are taken into account and are compatible with the flight and the crew workload. It is also necessary to confirm that any applicable maintenance procedures described in the MEL dispatch conditions have been performed and are recorded in the technical logbook. The flight crew have to also assess the consequences of the inoperative equipment in combination with other possible or multiple failures. The complexity of their tasks can increase with multiple open MEL items. The captain has the final decision to accept the aircraft or can refuse to depart if they conclude that the number of open MEL items is impacting too much on the flight crew workload during a flight or erodes the margin of safety. As part of the dispatch, the maintenance crew has to define an equipment repair or replacement strategy at the earliest opportunity and order the necessary parts as soon as possible. It is important to confirm the time-limited MELs do not expire before the next confirmed maintenance opportunity. They should also take actions to prevent accumulation of multiple open MEL items, especially where they can directly impact the flight crew workload and increase the risk of multiple failure situations. Extended MEL items and the number of open MEL items can increase the workload and the complexity of these monitoring actions of the maintenance crews. It is important that both the maintenance crew, who are responsible to apply and close the MEL items, and the flight crew, who manage the dispatch conditions of the open MEL items during the flight, are aware of each other's tasks. They can better assess the operational consequences of their decisions and find more appropriate solutions to reduce the risks associated with multiple open MEL item situations.